Hello guys, welcome back to Artificial and Facts. In this video, I will explain the inferences about pairs of treatment means and how to use SPSS. Suppose that we carry out the Anaphor procedure and make this decision to reject the null hypothesis. This allows us to conclude that all the treatment means are not the same. Sometimes we may be satisfied with this conclusion, but in other instances we may want to know which treatment means differ. This section provides the detail for such a test. Before we go further, let's know about the Anaphor procedure. The Anaphor procedure performs analysis of variance for balanced data from a wide variety of experimental design. In analysis of variance, a continuous response variable, known as a dependent variable, is measured under experimental conditions identified by classification variables, known as the independent variables. The variation in the response is assumed to be due to effect in the classification, with random error counting for the remaining of variation. When we reject the null hypothesis and conclude that all the treatment or population means are not equal, we may want to know which treatment means differ. If the student opinion do differ, the question is between which groups do the treatment means differ. The simple way to answer the question is through confidence interval. The formula for the confidence interval for the difference in the treatment mean, the interval for between the two populations is as follows: x bar 1 minus x bar 2 plus minus t square root MSE 1 divided by n plus 1 divided by n2, where x bar 1 is the mean of the first sample, x bar 2 is the mean of the second sample, t is the degrees of freedom is equal to n minus k, MSE is the mean square error term obtained from the Anaphor table, n1 is the number of observations in the first sample, n2 is the number of observations in the second sample. How do we decide whether there is difference in the treatment means? If the confidence interval includes 0, there is not a difference between a treatment means. For example, if the left endpoint of the confidence interval has a negative sign and the right endpoint have a positive sign, the interval includes 0 and the two means do not differ. So, if we develop a confidence interval from the formula and find the difference in the sample means was 5.00, that is, if x bar 1 minus x bar 2 is equal 5 and the t square roots MEC 1 divided by n1 plus 1 divided by n2 is equal 12, the confidence interval would range from minus 7.00 up to 17.00. To put it in symbols, x bar 1 minus x bar 2 plus minus t square roots MSE 1 divided by n1 plus 1 divided by n2 is equal 5.00 plus minus 12.00 is equal minus 7.00 up to 17.00. Note that 0 is included in this interval. Therefore, we conclude that there's no significant difference in the selected treatment's means. On the other hand, if the endpoints of the confidence interval have a same sign, this indicates that the treatment means differ. For example, if x bar 1 minus x bar 2 is equal minus 0.35 and t square root MSE 1 divided by n1 plus 1 divided by n2 is equal 0.25, the confidence interval would range from minus 0.60 up to minus 0.10 because minus 0.60 and minus 0.10 have a same sign, both negative. 0 is not in the interval, and we conclude that this treatment means differ.
Like many statistical procedures, the pair sample t-test has two competing hypotheses, the null hypothesis and the alternative hypothesis. The null hypothesis assumes that the true mean difference between the pair sample is 0. Under this model, all observable differences are explained by random variation. Conversely, the alternative hypothesis assumes that the true mean difference between the pair sample tests is not equal to 0. The parity test is a method used to test whether the mean difference between pairs of measurement is 0 or not. The parity test is also known as a dependent sample t-test, the parity difference t-test, the match parity test, and the repeat sample t-test. For the parity test, we need two variables. One variable defines the pairs for the observation. The second variable is a measurement. Sometimes we already have the pair differences for the measurement variable. Other times, we have separate variable for before and after measurement for each pair and need to calculate the differences. For the example, a group of people with dry skin use a medicated lotion on one arm and a non-medicated lotion on their other arm. After a week, a doctor measures the redness on each arm. We want to know if the medicated lotion is better than the non-medicated lotion. We need this by finding out if the arm with medicated lotion has less redness than the other arm. Since we have pairs of measurements for each person, we find the differences. Then we test if the mean difference is 0 or not. So guys, we're in SPSS now, and we will compare the average pair with SPSS. And for the name, we rename, for example, first is PA and second is PB. And the label same as name, which is PA and PB because it just sample. And for the measure, we choose scale. And after this, for the data, we got it from BPS or Badan Pusat Statistik in North Sulawesi Province. In about inflation in 2017 to 2018. And we download the Excel. And here's the data in Excel. After that, we copy the data from 2017 and 2018, the inflation data. After that, we paste to data view in SPSS and we will compare the data. After that, we choose analyze, we choose compares means, and we click paired sample t-test. And in here, we get it in PA in variable 1 and PB in variable 2. After that, we click Bootstrap. We check list performance bootstrapping and make the interval is 95 and OK. And this is the result of the compare using t-test. You guys can see in the result for the means in 2017, PA is higher than 2018. And for the correlation between PA and PB after doing paired sample is 0.292, and for the significant is 0.357. And it means the correlation between two variables between PA and PB or the inflation in 2017 and 2018, the correlation is not strong. From this material, we know the similarities in the two paired data. The purpose of this test is to see if there is a role for the average between two paired or related samples. Because it is a pair, then the data from both samples must have the same amount or come from the same source. Thank you guys for watching this video. Don't forget to like, comment, subscribe, and share to your friends. And I'll see you next time.